Bright Tuty. Every student matters.
Now, in terms of temperature, till so far, in the previous classes, you had learned that degree Celsius and degree Fahrenheit are the two ways how the temperature is measured. Now, from this class onwards, we are going to have the SI unit of temperature as the mode of measurement of temperature, and that is Kelvin. Now, what is Kelvin? Kelvin is written as K and we do not add degree to it. Another important thing about Kelvin is that it does not have any negative values. Alright. Now, important thing about Kelvin that it is found that 0 degrees Celsius is equal to 273 Kelvin. So, if I have to see what is the boiling point of water, that we know that it is 100 degrees Celsius, which will be equal to 273 Kelvin plus 100. That means the boiling point of water in terms of Kelvin is 373. Alright. Now, taking this into account, let us solve this numerical problems. Alright, now let us solve this question. Convert the following temperature to Celsius scale. The first one is A 300 Kelvin. Now as you know that 0 degrees Celsius is equal to 273 Kelvin. So 300 Kelvin will be equal to 300 minus 273 degree Celsius, which is equal to 27 degree Celsius. That is your A. Whereas in case of B, it is going to be 573 minus 273 degree Celsius, which is equal to 300 degree Celsius. Fine. Now let's go to the next one. What is the physical state of water at 250 degree Celsius? What do you think it would be? Definitely water would be in the vapor state. Why vapor state? Because we know that the water gets converted into the gaseous state at 100 degree Celsius. So at 250 degree, it will start boiling and get converted into the gaseous state. So the water will be in the vapor state or in the gaseous state. In this case, in number B, what do you think water would be? Definitely, we had already seen in the latent heat activity that the water in this state at 100 degrees Celsius can exist in both the liquid state as well as in the gaseous state. So water will exist in the gaseous state and the liquid state at 100 degree Celsius. Let's do the next one. For any substance, why does the temperature remain constant during the change of state? Why do you think so? I had already explained you. The temperature remains constant during the change of state because the energy that we give to the system is used up in breaking the intermolecular forces of attraction that exist between the particles. So that energy is used up to break the intermolecular forces of attraction, to give them enough energy so that they can free from their stationary state, space up and thus start their random motion. As we do so, their kinetic energy changes, it increases and thus they get converted into the next state. So when we are giving energy to the system, this energy is used up in breaking the intermolecular forces of attraction so that that space is available and thus the temperature change does not get detected. Fine. Next question, suggest a method to liquefy atmospheric gases. Now that is very simple. You already know that you can change one state of matter to the next state by changing the temperature as well as changing the pressure. Now, in case of gases, we know that at normal room temperature, the atmosphere is in the gaseous state. So, at normal atmospheric pressure and room temperature, the air exists in the gaseous state. So, how would you convert them into the liquid state? Definitely by reducing the temperature and by increasing the pressure. So, when you reduce the temperature by reducing the temperature and also by increasing the pressure, we will be able to convert the atmospheric gases into the liquid state. Because the moment you exert pressure and you are reducing the temperature, it will force the particles to come closer to one another and thus get converted into the liquid state.